Stanford University.
All right, well, welcome then to lecture, what is this? Lecture 10? Not sure, lecture 10, I think, CS193P. Today, I'm going to briefly at the beginning talk about a couple UI elements, UI tab bar controller and UI navigation item, which is a property in UI view controller that lets you customize what your view controller looks like when it's inside of a navigation controller. And then we're going to get the meat of today, which is blocks. Okay, so blocks is a language feature. It has a little bit kind of funky syntax, takes some getting used to. That's why I don't really teach it back at the beginning when I'm teaching Objective-C syntax in general. So, you know, it might take some time to sink in and absorb how we do it, but in the demo I'm going to show using it, and over time you'll start to understand, oh, I see how these blocks work. Okay, but they're really important because we do all our multi-threaded stuff in iOS using blocks. So this is a syntax you are going to eventually have to master, because you can't really build a sophisticated program in iOS without multiple threads. Okay, because you want the main thread, the UI thread, to be constantly responding to the user. You never want it blocked. All right, so briefly, UI tab bar controller. You've seen this in iPhone, iOS apps. It's the little black buttons at the bottom here. And so, for example, this is the clock app, and you can see that as I click on the tabs going from left to right, it shows me a different view controller. Okay, this could not be more straightforward. And now that you understand how view controllers work, this is just very simple. It's kind of like a navigation controller, but instead of pushing it and sliding things away as it goes over and then having back buttons, you just have these tab bar button at the bottom, and as you click on it, it shows you a different view controller. So there will be 4 different view controllers here inside of this tab bar controller. Okay, very, very simple. Of course, the tab bar controller can have more than 4 tabs, and we'll show you how that works in a second. You create a tab bar controller just by dragging it out in Xcode and then control dragging from the tab bar controller to all the view controllers you want to be tabs. Okay, so it's exactly what you expect. It's very similar again to when you control drag from a navigation controller to set the root view controller, or you control drag from split view controller to the master and the detail. Exactly the same. Okay, same kind of mechanism. When you do that control dragging to all those view controllers, you're essentially setting this property in UI tab bar controller called view controllers. It's an NS array of UI view controllers, and you're basically just setting it, again, very similar like in split view. You're setting this same property in split view when you could do the control drag, but there can only be 2 in split view because it only has master and detail. Here you can have any number of view controllers. The little tabs, how do you control those? By default, the name on the tab will be the title of your UI view controller. Your UI view controller has a property called title. It's an NS string, and you pretty much want to set the title on your view controller because depending on what environment it's in, the title might appear in different places, like the navigation controller, it'll appear at the little navigation bar at the top, and with tab bars it appears down here at the bottom. And by default, your little tab bar thing will have no image, but this is really not very useful to have the title and no image, so you usually set the title and image in Xcode directly. You click on the tab bar button and you just edit it directly. Set the title and the image you want right there. When you're doing that, you're actually modifying an object that is a property on UI view controller. Remember that each tab, each UI view controller in each tab, it has to have the information about its image and its title. It's not stored by the UI tab controller itself. It's stored by each UI view controller. That's the object-oriented way, right? If we add more view controllers, they carry with them the information for their little tab button at the bottom. And so the property, the object in UI view controller is called tab bar item. It's a UI tab bar item star, right? A pointer to UI tab bar item. And the UI tab bar item has properties on it like title and image, and also some kind of interesting ones like badge value. So you've probably seen badges in iPhone apps, little red circles with numbers in it, like how many mail messages you haven't looked at and things like that. So you can actually set the badge item by saying, in a view controller, by saying self.tabBarItem.badgeValue equals some string. Okay, and then it will set that thing. So tab bar item is the key way to do that. And we're going to talk about how to do the same thing in a navigation controller, which we kind of skipped last time, so I'm going to bring it up to speed. what if we have more than 4? What happens is that you get a more button at the bottom. You see the right thing at the very right, the button at the very bottom right. And when you click on the more, you get this area where the user can choose which of the more than 4 they want to appear at the bottom. Okay, and they can do this at any time. And the great thing about this, it's all automatic. You don't need to do anything in your code. There's no delegate or anything you need to do. It'll keep track of this for you. Okay, so that's a nice feature. How about combining? Can I combine UI navigation controller and tab bar controllers in the same UI? And the answer is absolutely. In fact, it's quite common to do so. But the one thing to think about is that the navigation controller is always inside the tab bar controller. Okay, in other words, when you drag them out in Xcode, you would never control drag from a navigation controller to put a tab bar controller as its root view controller. You'd go the other way around, where you control drag from a tab bar controller to make some navigation controller be one of its 4 tabs. Okay? So in other words, it's always inside. Even though in the UI it might look like one's inside the other, it's always the navigation controller inside the tab bar controller. How about tab bar controller and split view controller? You can combine those as well. And obviously the tab bar controller will be inside the split view controller, either inside the master or inside the detail, or possibly both. That would be a little bit of an unusual UI, I think. But, all right. So here's what a combination would look like, right? I got a tab bar, and then inside the tab bar there's a navigation controller. Right? This happens to be a table view controller on the left, some kind of generic UI view controller on the right. Make sense? You've seen that before, I'm sure. Okay, yeah, so this is a little bit going back to navigation controller. Just like there's a tab bar item object in view controller that controls what the tab bar looks like for a particular UI view controller that's in a tab bar controller, there's also a property called navigation item, which is an object, a UI navigation item star. And that object has some properties on it that control what the navigation controller looks like when it's showing your UI view controller. So this is a property on UI view controller, not a property on UI navigation controller. People get confused about that, all right? Because each time a new view controller slides in a navigation controller, well, things might change in the navigation controller. For example, the left and right buttons. Okay, that's the buttons at the top of the navigation controller. Those are outside of the view controller that's being displayed, right? They're in the navigation controller's UI. But they're controlled, what's there is controlled, except for the back button generally, by what's in whatever view controller is being shown. Okay, so there's methods in navigation item like left bar button item, which you would only set if it's the root view controller, because normally that's where the back button is. There's also back button item, so that if you're not the root view controller, you can control what the back button item looks like, what image is in it or whatever. Some restrictions there on what the back button is allowed to look like. And the title can actually be a view. And we might see later in this course, we'll do a demo where we put a view in there. Instead of just having the word title, or the title of the view as a word, we might have a view in there that the user can interact with. If you have the toolbar button, if you, on your navigation controller, you can flip a switch in Xcode that says show a toolbar at the bottom of my navigation controller. Those toolbar buttons are also controlled by whatever UI view controller is being shown at the time, whatever's slid on. But it's not controlled by the navigation item property. That's a different property called toolbar items, which is an NS array of UI bar button items. Okay, so if you set toolbar items array to something on your view controller, whenever your view controller slides on screen in a navigation controller, the buttons at the bottom will show, assuming that that navigation controller shows the bottom bar button, the little bar. Okay, if it's not showing that bar, then your buttons won't appear. Okay, so that's it. So tab bar controller and navigation controller are very similar. They're just presenting UI views. They're controllers of controllers. But they both use the same concept of having an object in the view controller they're displaying that controls a little bit of how they display. Okay, that's it for tab bar controller. I'm probably not going to get in the demo today to showing you how to hook up a tab bar controller. You are required to do that for your homework, so you're going to have to figure that one out on your own, but it's control drag. You'll figure it out. All right, blocks. So what is a block? And every time I refer to a block in the slides, I'm going to put it in this kind of green color so that we know we're talking about blocks, the thing that we're talking about, blocks, okay? As opposed to the word block meaning like blocking a thread, stopping it from running. That's a different block. So what is a block? A block is a block of code. that is to say, a sequence of instructions of code, this Objective-C code between open and closed curly braces that you usually include inline, right in the middle of your code, okay? But it can be passed around and assigned in local variables and passed as an argument. So you can basically be passing this curly braced thing around to methods. Storing it in data structures like NS dictionaries and stuff like that is pretty flexible and remarkable. And we're going to see why we would want to do this. And also we're going to see the syntax for declaring and defining all this stuff in the next few slides. All right, so what does it look like? What does this syntax look like? Well, let's start with the syntax of what if I had a method that I wanted to pass a block to? What would that look like? So here's a method that actually exists. It's in NS dictionary. It's called enumerate keys and objects using blocks, using block, okay? And it takes only one argument, which is a block, okay? This block, the block takes 3 arguments. All right, so the method enumerating keys and using object using block takes 1 argument, which is a block, but that block takes 3 arguments. The 3 arguments of that block are the key and the value, and a Boolean, that's actually a bool star, because it's an kind of an outgoing argument, that is going to pass you all the keys and values in this dictionary one at a time to this block. So that's what enumerate keys and objects using block does. It basically enumerates, shows you all the keys and values in this dictionary, and for each one, it's going to execute this block, the stuff between the curly braces. Everyone with me so far? Any question about this? Really important to understand this very first thing we're talking about here. This is about passing a block, a sequence of Objective-C, a little piece of Objective-C code to another method, and it's going to call it repeatedly in this case. With certain arguments. So, for example, the code above would go through and log using NSLog. You see that's the first line of code inside the block. And it's just going to log every key and value inside this dictionary until it finds a key enough, all caps, then it will stop. And it'll stop by dereferencing that bool star. Hopefully you all know C enough to know what's going on there. Star stop equals yes is going to set the bool that bool star points to tell it to stop. Okay, and then it'll stop enumerating, stop calling this block with all the keys and values. Okay, questions about that? All right, so this is a classic case of where we would use blocks. Now, blocks, the syntax, we're going to start talking about the syntax, and it's somewhat convoluted. Okay, it's pretty simple here to start, but it gets a little more complicated. But the most important thing about blocks is this magic character, the caret. Do you see how there's a caret right at the beginning of enumerate keys and an object using blocks, colon? The very first thing, there's a caret. That means this is a block. Okay, we always have a caret. If you see a caret, it means there's a block involved. Okay, so caret is the first magic. Now, when you have something like this, it's kind of amazing. You might find this hard to believe. But if you had a local variable declared on the line before you called enumerate keys and objects using blocks, you can use that local variable inside the block. Okay? So this takes some sinking in too. Okay? This is a local variable on the stack of some method, and you call enumerate keys and objects using block, and you pass the block, and inside that block you're using a local variable from the outer scope. Perfectly legal. One thing about those, though, they're read-only. Okay? So you cannot say, for example, the red line there, stopped early equals yes, because stopped early is a bool on the stack locally outside this scope, and so you can't say stopped early equals yes there. You see? Okay, so they're read-only. However, if you put underbar block in front of it, now it becomes read-write. And not only that, after the blocks are done executing, at the bottom, it'll have its value. Okay? So here we got stopped early equals no. I put underbar block in front of it. Now the stopped early equals yes is legal inside that block. And when this enumerate keys and objects using block method is done, that stopped early will have whatever value it had when the last block touched it. Okay? So I could say if stopped early, then log I stopped logging dictionary values early. Okay? So that's pretty cool. And underbar block, I know it has underbar at the front, and it's like, that's weird, underbar. And it is kind of weird, but I wouldn't resort to using underbar block as your first design strategy for a little piece of code, but it's not like, oh, this is something you should stay away from, even though it has that weird underbar name. The other interesting thing is if you use an instance variable inside a block, it will be valid when it comes out and also not be read-only. Okay? Now, we don't use instance variables in this class, okay, because we use properties, right? The only time we're ever accessing an instance variable is in the setter and getter. Right? Instance variables are like when we say @ property display equals underbar display. That underbar display is the instance variable that's backing the property. We're only supposed to access that in our setter and getter, right? So, unless we're doing some sort of block thing in our setter and getter, it's not really that valuable. But it's interesting to know that instance variables are not read-only, i.e. they can be read and written to, and they'll be, affected after the block comes back. Okay, what about accessing objects inside the block? All right, so here I have a local variable called stop key. It's an NS string, just a local variable. It's enough, all caps, but I made it by sending the message uppercase string to enough, not uppercase, and so that I just wanted to show you that stop key doesn't have to be a constant. It could be the result of calculating something or calling some other method. But anyway, it's on the stack, and then I enter this block. And so let's say inside the block, instead of testing for quote @ enough, all caps, I say stop key is equal to string key. So the only thing I've changed here is I'm using stop key instead of @ enough. Okay, everything else is the same. So there's a little bit of an interesting thing to think about here, and this works fine. Okay, stop key, it's read-only in terms of you couldn't set the stop key pointer unless you put under a block, but it's kind of writable in that you can send messages to it all you want. Okay, and those messages might modify. You might set a property on stop key or something if it were something that had properties. But there's a little bit of a memory thing to think about here. Okay, because this block, in this particular method, the block gets executed pretty much right away, which is fine. But what if this block were just held onto by the dictionary and it executed at some later time? Okay? Well, in that case, stop key better stay in memory. It better stay in the heap. And the problem is stop key is a local variable. So when this thing goes out of scope, stop key would stop, no one would have a strong pointer to it, and it would normally get thrown out of the key heap. So the key on this slide is that objects that are referenced inside a block, the block keeps a strong pointer to them. Okay? The block keeps a strong pointer to them until the block goes away, until the block can't be run anymore. Okay? And you can see why this would be, right? That block might be running on another thread at some future time. Let me show you another example that's maybe a little closer to home here, which is what if we went back to our calculator brains and we added a method called add unary operation, took a string, which is the name of the operation, like whatever title on a button, like square root, which executes block : a block. In other words, what if we were able to tell our calculator brain, hey, here, add this new function to yourself, and here's the block of code to execute. Okay? That'd be cool, wouldn't it? Because we'd have now a fully extensible calculator brain. We could add new unary operations all we wanted. We could also add binary operation, add operation without any arguments. We could have a bunch of this stuff. But we're going to focus on add unary operation because I want to show you what it would look like to use a block in the implementation of a method. So how you would make a method that takes a block as an argument. So the block that we pass in this case, right, the little piece of code to execute for our custom operation, is not going to be executed right now. It gets executed later when someone presses that button with that name, right? So our calculator brain, in other words, is going to hold on to this block. So for example, what if we added this unary operation? So I have this unary operation, MOLTUAE, which is short for the meaning of life, the universe, and everything. And what if I had a local variable, secret, which is a number, NS number, and I set it to 42, okay? And then I added my unary operation, multua, which executes block, this block. Now, my block takes one argument, which is an operand, and it returns an operand time the secret double value. Okay? So obviously if I called this, if I executed this line of code, I would want secret to stay around as long as that block stays around. So that if someone has an MOLTUAE button in their calculator and they're pressing it and it's executing this block for me, that secret doesn't go away, because then I wouldn't know the meaning of life, the universe, and everything, and I couldn't calculate this block, right? So does that make sense as to why we have to keep a strong pointer to that secret? Okay, so that's going to cause a problem, keeping that strong pointer, which we'll get to in a few slides. But before we get to that, let's talk about how we, the syntax for declaring all this stuff. And usually to make life simpler on ourselves, so that it's a little easier to understand this with this caret and all these parentheses and curly braces all over the place, we usually create a type. We do type def. Everyone know what a type def is in C? That's where you can kind of define your own type. Okay, like you could type def something to be a double, like CG float, right? The CG float in core graphics, somewhere in the header files, that's type def to be either a float or a double or whatever we want on that platform. Okay, so we're going to type def a type, a new type, for a variable whose value is a block. Okay? And so what would that look like? And it's kind of tortuous. It has its roots a little bit in C function pointers. Okay? It's a little bit like that. But here's, you just basically got to take my word for it and look at it and use the piece, find out where the pieces go. But here I'm type defing a block, in this case, which takes a double as an argument. That's the double op on the right. And it returns a double. That's the double right after the word type def. Okay? And then I'm doing parentheses caret and then the name of the type. So like CG float is the name of a type. Here the name of this type is unary underbar operation underbar T. A lot of times when we define a type, we put that underbar T at the end just to make sure we realize, oh yeah, this symbol is a type we defined. Okay, so that line of code, type def double, unary operation T double op, defines a new type, which is a block that takes a double and returns a double. And the name of the type is unary underbar operation underbar T. Now that we have this type, we can declare a variable of that type called square. See, I say unary underbar operation underbar T square. That's just like saying CG float F or something like that. And then I can assign that square a value by saying square equals caret, double operand, curly brace, return, whatever. Okay? So I'm assigning a value to square. It's getting a value. The value is a block of code. So now that I have this variable square, which is of type unary operation T, I can use it. How do I use it? I use it very much like a C function looks. I could declare a double called square of 5 and say it equals square of 5.0. I'm passing 5.0 into that block. 5.0 is the operand argument in the block. It does operand times operand, that's 25. Square of 5 would get the value of 25. Okay? I know this is unusual syntax. You're probably, unless you're really into C function pointers, you're probably a little bit like, okay, I'll take your word for it. But it'll sink in over time. You don't have to do the type def. For example, here's how you would just declare square directly without the type def. You'd say double caret square. That square is now the variable value, not the name of the type. Double op equals caret, double op, curly brace, return op times op. Okay, so you can see a lot of curly braces and parentheses. So you can see why we do the type def. It makes it a little clearer what's going on. Okay, but once we had a unary operation T, this type that points to a block like that, we can use it to declare functions and arguments to functions that take arguments to function. Okay, methods that take arguments of that type as arguments. For example, add unary operation which executes block. Okay, its second argument is a block that takes a double and returns a double. So we could use unary operation T to declare that method. So here's what it would look like. So let's example first, we're going to add a property to our calculator brain, which is an NS mutable dictionary called unary operations. So it's just a dictionary that's going to hold all of our unary operations. A dictionary, remember, key value. And then we would implement add unary operation which executes block like this. Add unary operation string op, so that's like the MOLTUAE whatever, which executes block colon the type unary operation T op block. Right? So we're saying that the second argument to this method is a block. And unary operation T describes what kind of block. Then the implementation is a one-liner. We just add to our dictionary that block for the given key. Now, notice that we're treating a block like it's an object. You see how we're adding it? We're saying set object, a block, for key, this string. And we can do this, and it's perfectly legal, and blocks are kind of like objects. They're not really objects, though. They're similar to objects. You really don't send them any other messages. You don't send them messages like you're used to sending messages for objects, but you can put them any place an ID goes, like in an array or a dictionary or whatever. Okay? And with Arc, with the introduction of Arc in iOS 5, the memory management of this block, since it's not really an object, the memory management is managed by Arc. So you don't have to worry about it. When it's done being used, its heap space will get automatically freed up. Okay? So later then, so if we had this dictionary whose keys were operation strings like MOLTUAE and whose values are blocks like return, secret number, double value times the operand, then we could use it like this. Remember perform operation in your calculator brain? We could say unary operation T unary op equals look up this operation in our dictionary, right? So we're getting the block back out. It's type unary operation T. And then if it's not nil, in other words, we found it in the dictionary, then we're just going to say self.operand equals unary op, the operand. Got it? So we're using that function notation. Same way we did square. We did square of 5 equals square of 5. Same thing here. Self.operand equals unary op, self.operand. Okay? All right. So I know. It's hard to follow a little bit sometimes. Now, we don't always type def. Okay? A lot of times we will not use a type def to declare a method. For example, here's the declaration of enumerate keys and objects using block. It just directly says that it is a block. It has no return value. That's why the little void is there. Notice the parentheses, caret, parentheses. There's nothing inside the parentheses with the caret because we're not defining a type and we're not defining a variable here. We're just we're just defining what the type of the variable op block, or block, I guess is called there, is. So we don't need to have anything in there with the caret. And then any arguments that this block needs to take, and then block. Now block, that keyword is like the local variable inside the implementation of enumerate keys and objects using block. Okay, you got to look at everything between the colon and the start of the word block. That's the type of block. All right? So if we type defed it, it would look almost the same, except for we'd have a word like enumerating block or something like that, or enumerating block under bar T or something would be our type name, the underlying part. So that's just taken out because we're not going to do that. Okay, so blocks are so common, and this stuff is so convoluted, that actually we often have a shorthand when using blocks. And there's two things in the shorthand that we do. One is you do not have to declare the return type of a block if it can be inferred from what's inside the block. So for example, when we add unary operation T, I don't have to actually say that it returns a bool, because look inside. Return operand star times secret double value, that returns a double, because if I look inside and see operand times secret double value, that obviously returns a double, and so the system will say, okay, I understand this block returns a double. You don't have to tell me it does. The other thing, if there are no arguments to a block, then you don't need the parentheses. You don't have to have open parentheses, closed parentheses. For example, here's a UI view class method called animate with duration, and its second argument is a block of animations to do, and you can see it just says caret curly brace. It takes no arguments, returns nothing, so it's just caret curly brace. And we're going to see when we do the multi-threading that the blocks that we put on the queue to run in other threads, they also take no arguments and return nothing. So we just say caret curly brace and start putting the code we want to run in the other thread. Okay, so that's a little shorthand there. All right, so the memory cycles, this is a bad thing. And I'm going to show you how you solve this, and it's a little odd. If you don't really get what I'm saying here, you can go stare at these slides later. Your homework will not be required to do anything like this, so you don't have to worry about this. But if I taught you blocks without talking about this problem, I would not be doing you a service. So you got to know that this problem exists, okay? And this problem is memory cycles. So what if I had a class that had a property, an NS array of blocks? Okay? And then what if I tried to add somewhere inside the implementation of that class an object which took a block whose implementation referred to self? Okay? So I'm putting a block onto a property of myself, and inside that block I refer to myself. Okay? This is going to create a memory cycle. And that's because the block has to have a strong pointer to self. Okay? Remember I said any object inside the block needs a strong pointer. And at the same time, we have a strong pointer to the block because we have a pointer to this array, and the array has a strong pointer to the block. So now both of us have strong pointers to each other. Neither of us can ever escape the heap. Okay? Because never is it going to be a situation where one of us has no strong pointers left to the other. Okay? So that's bad. That's a memory cycle. That's going to leak memory. It's going to keep these two objects in memory forever. So how do we get out of this? There's a magic underbar, just like underbar block. There's another magic one called underbar weak. And what underbar weak says is this local variable, remember that local variables are strong by default. Underbar weak says this local variable is weak. Okay? This is a special kind of local variable. It's weak. And we just say underbar weak. My class star weak self equals self. So we're having a weak pointer that points to the same place in the heap as self, but it's a weak pointer to that place in memory. And then we use the weak self inside the block. Now the block does not have a strong pointer, okay, to self. It has this weak pointer. Make sense? And so now we're fine, because once we go away out of the heap, the block can go away too, because we're going to be allowed to go away because the block's not pointing to us strongly. So once everyone else who's pointing to us strongly goes away, then our block can go away too. All right? Question?
Why doesn't it automatically do that?
The question is, why doesn't it automatically do that? The answer is there's no deterministic way to know when you don't want the pointer inside to be held strongly. It might be that you want self to strongly be held there. Okay, because you might be passing this block to someone else, and then you're releasing your strong pointer to self, and you do want self to stay around until that block is done being used, you see? So it's only in this kind of case where there's no way for the compiler to know that you have a strong pointer to the block at the same time the block has a strong pointer to you. It's kind of non-deterministic to find that out. So anyway, so you got to know about this thing. Not for homework in this class, though. You're never going to have to do underbar weak in this class. Okay. So when do we use blocks in iOS? We use it for enumeration. I showed you that example. For view animations, I actually showed you a brief example of that. For sorting, where we say to an array, sort and decide what the order of things is by executing this block on the things inside the array or whatever. We use it for notification, which is execute this block when something happens. We use it for error handlers. If an error happens, please execute this block. For completion handlers too. Go off and animate this thing, and when you're all done animating it, call this completion handler so I can set some state. Okay? But the number one place that we use blocks is for multi-threading. Okay? And we do that with this C API, not an object-oriented API, C API called Grand Central Dispatch. Okay? And this is what Grand Central Dispatch looks like. The idea in Grand Central Dispatch is that you have queues of operations. Everyone know what a queue is, right? A queue is a thing like you go to the bank and you get in the queue, okay? You come in on the end of the queue and there's people in front of you and the teller helps them and they go off the queue and the queue just goes on. Same thing here. We're going to put a queue of blocks, okay? And these blocks are going to be pulled off the queue and run in some other thread. Okay? Question?
When you say it's C API, does that mean it can be called outside of Objective-C, which is part of the standard C libraries?
Yeah, so the question is, when I say C API, that means, can I call this outside of Objective-C? It's included in the same runtimes as the Objective-C runtime, but yeah, it could conceivably, you could have a library that has Grand Central Dispatch, and probably there exists that. You probably could do it. No Objective-C, not even
Is it not standard, though, in C, in the language?
No, it's not a standard C thing. The question is GCD a standard C thing? And the answer is no. It's an Apple mechanism that's been put in for multi-threading. All right, so you have this queue of blocks, and you're going to pull these blocks. The system is going to pull these blocks off and run them. And there are concurrent queues where if you had multiple processors or multiple cores, it could pull the blocks off and run them concurrently, but we're not going to talk about that in this class. And in fact, in iOS 5 adds some nice new features for concurrent blocks. But we're going to talk about serial queues, where it's only going to pull off one at a time. It won't pull the next one off the queue until the previous one's done. So it's kind of a true queue. Okay, so that's what we're going to talk about today, serial queues. The key, though, is that these blocks get pulled off the queue and run in another thread. That is the main deal here for us. Now, so you've got these queues, and they're off running blocks, curly braced blocks, in other threads, but you also have this main queue, and the main queue is where all the UI kit stuff happens, all the drawing. Okay, that queue we want to make sure we're not ever putting anything on there that's not having to do with UI, because we always want that queue to be free to respond to gestures and things like that. So the way we're going to do multi-threadedness is we're going to queue up blocks for things that take a long time, let them run in other threads, and then from those threads we'll queue up blocks to run back on the main thread to update the UI. Okay, you will see this when I show you an example. And this allows us to get all this blocking activity, like accessing the network or doing something really expensive in another thread. Okay? What are the important functions in this API? You've got dispatch queue create. That creates a queue. Okay, a queue that I'm going to start putting blocks on. Then dispatch async is a C function that puts a block on the queue. And at some time, undetermined in the future, someone will come along, take that block off, and run it in another thread for us. It's as simple as that. That is all there is to this thing. Okay? Now, there's more mechanism in there if you want to do sophisticated things, but for our purposes in serial, you create a queue, you dispatch async, off you go. There's two interesting methods here to get the current queue. Sometimes someone will call you with a block and ask you to do something, and you want to do part of it on another thread, and so you want to know the queue that the caller was in, right? So the queue you're currently executing in, because you might want to go, after you've run something in a thread, send a message back on that queue that called you. But even more importantly, you want this get main queue. That's the UI kit queue. Okay, and that's where you want to run any code that touches the UI. If you run UI kit code in a block that's posted to any other queue besides the main queue, you will have problems in your app. It will behave badly, you'll get crashes. You do not do it. Listen to me right now. UI kit stuff only in the main queue. So if you're doing something in another queue and you need to do a UI kit thing, go put a block back on the main queue to go do that thing, right there where you are in your code. All right, so what does it look like to call these? Let's make this concrete. So let's say I have a method that goes out to the network and gets some contents of some URL, like a Flickr photo image, for those of you who have started your homework. And then I create a UI image with that data, and then I have an image view that I set its image, and then I put it in a scroll view, let's say, so that it'll display. All right? So if I want, so that data with contents of URL, that method could take a long time. It could take like a few seconds to go out to a server on the network, get the Flickr photo, download. It could be a huge photo. That could take a long time. We do not want this code executing on the main queue, okay? Because the user interface will be completely non-responsive during this view will appear. And we do not want that. So what if we just create a queue, okay, download queue I'll call it. By the way, the dispatch queue create, the first argument to that is a const char star. This is the only time you're going to see a const char star in any API I'm going to talk about in this class. And that's, again, because this is a purely C API. This is not an object-oriented API, so it can't be an NS string. And that string, by the way, is just like in the debugger, you would see that thread, and that would just give it a name. That's really all it's used for. The null is just specifying whether this is a serial queue or a concurrent queue, and we're only doing serial queues, and null means serial queues. So I create this queue, then I just say dispatch async, and put this code that I want to run in another thread in a block. It's really that simple, except for a couple of things. One, UI kit calls can only happen in the main thread. So this is bad, because look at that self.imageView.image equals, self.imageView.frame equals, scrollView.content size equals. Those are all UI kit calls. Those can't be done in this other thread. So how do we fix that? We simply move that code, the UI kit code, back onto the main queue. Okay? This is the power of GCD, is that as a programmer, you can think linearly through time, right in line. Okay? If things need to go back to another queue, just post them on the other queue. You don't have to be trying to get your head around when is this going to run, blah, blah. It runs time linear here. Okay? Things are passing off from queue to queue. And we just got to make sure that we put things on the right queue. And the right queue is just UI stuff has to happen on the main queue. Everything else can happen on other queues. Now, there's still a problem with this, which is the memory management of that download queue. These are not objects, these queues, right? They're C things. So you actually have to call this method dispatch release on the download queue. And what that says is, I'm otherwise done with this queue. And why I say it's otherwise done is I posted a block on it. So when I say release, I mean I'm done as long as there's no blocks left on this queue. Okay? So when I say dispatch release download queue, that's basically telling the system when there's no more blocks, you can release it as far as I'm concerned. Okay? So we always do that. So that's what we're going to do. So we'll get a little bit of table view and we'll get a little bit of GCD at the same time. All right, so let's go to our friendly Xcode. All right, so I'm going to create a new project here. I'll show you a couple of things why we're at this. I'll try to work this kind of little things in as we go along. But notice there's these other templates here. And like in this assignment, you might be tempted to use this tabbed application template because you need to do a tab bar. I tend to always do single view application, which is like the simplest template, and then just drag out a tab bar if you want one, drag out a split view if you want one, etc. Because a lot of these templates are going to add stuff that you're just going to be like, what is that? And you're going to be trying to figure it out, and it just might be more confusing than you buy as power. So here I'm going to say single view. I'm going to call this Shutterbug. That's the name of my thing. And I'm actually going to have no class prefix, because I want to show you what that looks like too. Okay? Because in the past, we've always had a class prefix like calculator or psychologist or whatever. We'll go ahead and make this universal, although I'm only going to have time to do the iPad. And of course, we want storyboards and reference counting. And we'll put this in developer where we always put stuff. All right, so here we go. So look over on the left here. You see app delegate and view controller. These are the two things that would have that class prefix, like calculator, view controller, or whatever. And, of course, if we go and look in our storyboard, they have made something here which is a view controller that is of this class, generic view controller. But I would never really want that. So it's perfectly fine, actually, to take this view controller stuff and just delete it, which is what I'm going to do. Just get rid of it. And, in fact, I can not only delete the source code, I would probably want to go back to my storyboards, both my storyboards, and delete the thing here, too. So my storyboards are completely blank. So this is a way to start with like a completely blank app. The other thing is this appdelegate.mnh. We haven't really talked about that yet, and we will in this class towards the end because there are some notifications that are interesting in there. But in iOS 5 with storyboards, you really almost never need to touch your app delegate. In fact, I usually drag them down into supporting files. Okay, these files down here that we don't really have to look at. So this is kind of like a blank app right here, right? Okay, so this is a good blank starting point. So this app that I'm going to build is a table view of Flickr photos. So I'm going to start by dragging out a table view. Right, here's a table view. And remember that when I put a table view into my app, this table view controller that has a table view and table view cell prototype in it, I usually almost always, if not always, want to create a subclass to make this customized. So I go here to UI view controller. This is the same thing I did before. We're going to call this one Flickr Photo Table View Controller. Okay, because that's what it does, holds table view of Flickr photos, and we're going to make sure our superclass is right. You don't want this zib thing, so you want that off, and it doesn't seem to matter what you do with this if you don't do that, so I don't think that matters. All right, so make sure we put it in the right place. That's fine. Here it is. So here's our Flickr Photo Table View Controller. Again, for the purpose of this demo, I'm going to remove a lot of this view lifecycle stuff. If you want to leave that in so that you remember what they're all called and all that, totally fine. I just clear it out so that it's easier to see what I'm typing. And I'm going to leave the orientation stuff in, okay, because I definitely want to be able to rotate, and we'll rotate all the time. And then here's my table view data source stuff, right? Sections, rows, the cell at each thing. This is for more advanced table view stuff like deleting rows and stuff like that. We'll get this out of here. This is the delegate down here where we have the did select row. I'm not actually going to use this today. I'm going to, just for fun, segue from the row in the table. Now, what is the model for this MVC going to look like? Right? I got this table view controller. It's the controller. What's the model look like? Well, I'm going to have this be very simple. It's going to be a property, which is non-atomic, strong. It's just going to be an array of Flickr photos. I'm going to, since it's public API here, I'm going to type this in. Now, I say of Flickr photo dictionaries. When you query Flickr, you get a whole bunch of stuff back. And I give you this code, this Flickr fetcher code for your homework. And what it gives you back is an NS array of NS dictionaries. And inside the NS dictionaries is information about a photo. Right? And we're going to have to look in there and see, you know, what photo stuff's in it. We're going to do that in a second, so we'll postpone that. But let's finish with our model. We obviously need a synthesize here. Photos equals underbar photos. And one other thing I'm going to do, which I didn't do last time and I kind of regret, is whenever someone sets my model, I allow my model to be set publicly here. So if anyone changes my model for any reason, then I'm going to set it, but I'm also going to reload my table view. Okay? And that's something you should generally be in the habit of doing. If you have a table view and you allow its model to be set publicly, well, if someone sets it, you should just reload the data for obvious reasons. Right? All right, so we have this photos. Now, how are we going to do the Flickr thing? So right now, it's just a generic thing. There's nothing, no Flickr data is coming down. So how are we going to load this Flickr information? And I'm going to do that with a button. Okay, so I'm going to, here's my table view, and I want to put a button at the top which is refresh or load from Flickr or something like that. How am I going to put a button at the top though? Yeah, I could go over here and drag out a toolbar and put it up like we did in the previous one, but there's a real simple way to put buttons at the top of a view, which is to pick a view controller and embed it in a navigation controller. Even if you're not going to do any pushing, it's a simple way to get a nice title bar, right, a toolbar at the top of your view. And you can set the title. We could call this photos or something like that. And I want this refresh button, so I'm just going to go down here and grab myself a bar button item, put it up here at the top. Okay, maybe call it refresh. And that was all easy to do embedded in a UI navigation controller. Right? So that might seem like it's cheating a little bit, but it's not really. You know, it's perfectly fine. So let's go ahead and get our space here. Let's wire this refresh button up. So I am going to make this refresh button. We'll have it send a private message. Okay, what's going on here? Let me see what's going on. Oh, sorry. One very important thing we forgot to do is this photo thing here is still a generic UI table view. So we need to inspect it and set its class to be our Flickr photo table view. So here, I forgot to do that. You'll forget to do that at least once. You'll start to notice it when you want to start making outlets, and it's like, what the? So that's exactly what happened here. So now that this is a Flickr photo table view, now when I go to create an outlet, you can see that it's showing me the Flickr photo table over here instead. So I'm just going to control drag to create an action. You all surely know how to do target action by now. And I'm going to call this refresh. Okay, this is going to refresh the Flickr photo. So the question is, how am I going to implement this refresh thing? Because what I want to do in here is self.photos equals something. Right? I want to set my model by querying Flickr somehow. All right, so I'm going to do that. To do that, we're going to drag in this code, this Flickr fetcher code that I give you. So here, let's just drag it in so we can take a look at it. All right, put this down in here. And it's asking me, do I want to copy the files in, which I'm going to. All right, so here's my Flickr fetcher. Here's the public API of the Flickr fetcher right over here. These methods right here are ones that are in the code that I gave you for your homework. I added this method right here just for this demo because I didn't want you to be confused and think that you have to use this for your homework. You don't. You will use this one for your homework. We're going to use this for both if we have time today. I don't know if we're going to have the time, but in what I post you will. But this little recent georeference photos here in Flickr Fetcher, it just queries Flickr and gets a list of recent photos that somebody's taken that are georeferenced, that have latitude and longitude. That's all it does, okay? An array of dictionaries. The dictionaries that come back have these keys in them, right? So it's got the title of the photo, it's got a unique ID, it's got the owner, right? The Flickr account owner who took the photo. So we're just going to build a table view that shows some of this information. All right. So when we go back here to self.photos, let's just do this in a separate line actually. I'm going to say array ns array with the capital A photos equals Flickr Fetcher. Got to go import here. Flickr Fetcher. By the way, that API key, see this API key file right here? You're going to need to go get your own API key and put it in there. Okay, and there's a link in the homework that tells you how to go to Flickr and get your own API key. It's free, and but you'll have to do that. So here's Flickr Fetcher and then recent georeference photos. Oop, that's not good. Not sure what happened there. Well, let's start again. All right. Okay, we're back. Maybe it's because I typed this ... got it confused. I don't know. So we lost our import Flickr Fetcher. All right, and we'll go like this again. All right, Flickr Fetcher, recent georeference photos. Okay, and actually I'm going to do this with the separate thing that I started to type, and you'll see why in a moment. Oops, equals, paste. And we'll just say that equals photos. All right, sorry for the delay there. All right, so that's how we're going to get the photos. Okay, by pressing this refresh button, it's going to call this Flickr Fetcher code that I'm giving you basically, and it's going to set the photos, which is an array of dictionaries, to be those photos. Everyone understand this code? All right, so now we need to implement our table view data source to look at our model and answer the questions. So one question is, how many sections in this table view? I have only one section in this table view. In the code that I post, kind of the lecture demo plus, I'll do sections, just so you can see what it looks like to have sections, because we haven't had any demos of that. But here I have one section, so I don't even need that method. This is number of rows in section. This is just how many photos we have, right? Simple as that. And then here's the all-powerful cell for row and index path, which gets a UI table view cell to display. This is something that we obviously need to set up inside our storyboard to define how we want this prototype to work. So let's inspect that. I don't want custom. I'm going to do subtitle, let's say. Maybe I'll have the title be the title of the photo, and then the subtitle maybe the owner name or something like that. And then very importantly, I need this reuse identifier. It's the name of the thing. When we pull it out of the reuse queue, if there's nothing in the reuse queue, we got to tell it what prototype to use. So this is basically a Flickr photo is what's in this cell. So I'll call that Flickr photo. And then when I go back here, I want to make sure that I type Flickr photo in this cell identifier as well. And if this doesn't match, then it's going to resort to this, which is kind of a fail-safe-ism. It's going to be the wrong type of cell. That's probably good, so I can see that that's happening. But hopefully it pulls a prototype by using this name. Configuring the cell is really easy. We just need to get the photo dictionary. And we get that by looking in our model and just getting the object that is at this section and row. Now, again, we only have one big section, so we only need the row there. And then I'm just going to set the cell's text label to be the photos object for key. And again, I'm just looking at those things that were in that Flickr Fetcher.h. So there's photo title we'll put there, and then we'll say that the detail text label, which is the little subtitle, equals the photo object for key Flickr photo owner, let's say. So owner. Okay? So by implementing this data source, we now are going to have the data in the UI. So that should be all we need, unless I've forgotten something, which is entirely possible, but we shall see. All right, so here's my table. I don't know if can you see? Yeah, you can see that. See the lines as I flick? They're kind of scrolling around, but there's no data in my table. But if I hit refresh, now, oops, refresh not working there. Okay, why is that? All right, let's see. Oh, no, that's not it. iPad, refresh. Hooked up to our table view controller. Okay. Yeah. Sorry, what was the other question? I set the API key. That's not it. The reload data, we have that. Yeah. Now we set the photos here, so really it's not even doing this because if we did this, then our API, our UI would block, obviously. So let's go ahead and, let's go do some on-the-fly debugging here. Let's go ahead and do this and see what's going on here. Let's press refresh. Okay, so it is blocking here. Let's try and step in here. Okay, there's our thing. There's our request. You know, one thing we can do, let's make a little... on these logs, we'll log what we're sending to Flickr. It might be that we're having a network issue or something, so let's go ahead and try that. That's not good in live demos, but what can you do? All right, so, oh yeah, here we go. Do we run? Hello.
Stop it and run it again.
Yeah, let's stop it and run it again here. Yeah, it's possible this iPad is not have network's not working or something. Okay, well, we might have to postpone this to next week. Yeah, let's try that. Let's try running on the simulator. That's a really good idea. Let's try that. iPad simulator. It's going to be kind of small, maybe hard to see, but. All right, let's see if that works. Oops, let's just, whoops, forget that. Let's continue. Okay, so this is working. All right, so something about this iPad. All right, so we'll do this on the little thing here. Very good idea there, thank you. Okay, so here is the result of doing this Flickr query. And one thing you can see, watch, I'll select a line here, which doesn't do anything because we haven't wired it up to anything. But when I hit refresh again, look, I'm trying to scroll, I can't do anything. My whole UI is frozen. Okay, so that is bad. That's very bad. You never want to write an app where your app freezes for any amount of time. Okay, users get completely confused by that. They're trying to figure out how to kill your app, and you get bad reports on your, App Store thing. So we definitely want to fix that. Okay, so that's what we're going to fix with GCD. So let's do that. That's a really good question, and I was going to show how we could filter out the ones without titles. The question is, why do some of the rows not have titles? Okay, some of the rows in there didn't have titles, and the answer is the Flickr photo has no title. And that looks ugly, and I'm like, I don't want that. So I was going to go and show you that by showing you how to use a block API to do that. It would have been great, except for now we don't have time. So I'm going to show you the GCD thing because that's way, way more important. I'll post that as part of the enhanced version. All right, so what's the problem? The problem is that this thing blocks, okay? And so we need to put this thing inside of a block that's going to run on another thread, okay? So let's do that. And it's really straightforward, actually, to do. We're just going to say dispatch QT, which is the type of a dispatch queue. We'll call this download queue. Equals, and we're going to create one. Make some more room here. So I'm going to create one, which is dispatch create. So here's dispatch queue create. We'll call this Flickr downloader and null because it's going to be a serial queue. We are always going to pass null in this class. And then I just need to say dispatch async onto this queue, right? So dispatch async takes two arguments. The queue I want to put it on, so the download queue, and the block I want to run. So I'm just going to say this block. So I'm going there, and I'm just going to put this stuff inside. Okay, and then I'm going to be very careful to make sure I do release of the download queue so I don't leak. All right. Now, this is great. This would do it on a queue, on another thread. We do this fetch on another thread. However, this is not so great because calling self equals photo is going to come down here and call this, which is going to call this. That's UI kit. Okay, we're up table view here. That's bad. So we can't do that. So this is where we do the nested calls, just like this. We're just going to say dispatch async, and this time we're going to say dispatch get the main queue. Okay, simple as that. And now this is the same. This is dispatch async again. So we just specify the block, and then we're just going to like this. Let's go ahead and put our semicolon there. Put this inside here, and that's all we need. Question?
How do you warn like other people in your public API that self.photos needs to be called in the main queue? Because if you're just setting the model, then it's not immediately. Yeah,
so that's a very good question. So the question is, how do you tell people in your API, your public API or whatever, that calling set photos, setting the model, is going to affect the UI, and thus you can't call set photos on anything but the main queue? And the answer to that is that this is a UI table view controller. Okay? Anything inside a UI table view controller, any public API has to be assumed to be modifying the table. Okay? So it's the other way around. If you had some public API that didn't require being run in the main queue, you could comment it and say, it's okay to call this. Otherwise, you got to assume all API that's in any subclass of a UI kit thing, like a table view controller, all of it, you have to assume has to be done in the main thread.
Why don't, like when we do set photos, we say self.tableview reload data, but in that, put that in the main queue. So self.
So the question is, why don't I say dispatch underbar, async, dispatch queue create, get main queue, all that right here, right? Is that your question?
Yeah.
And put that inside the block. And the answer is our code would be ridiculously complicated if we had to do that. We'd be having these dispatches all over the place every time we ever touch the UI. So we would never do that. It's easier to push the complexity back a level and say, don't call anything that has anything to do with the UI outside the main thread. So anyway, I believe that's all we have to do here. So let's go ahead and run this in our simulator. Yeah.
Can you force a warning if it's not in the main queue?
So the question is, can you force a warning if it's not in the main queue? And the answer is, it is possible to find out what queue something is dispatched in. You generally, you wouldn't warn the user, because the user doesn't know about threads. So I would say forcing a warning when something's not running in the main queue, I wouldn't do. Okay, that's up to you as programmers to not design things to do that. Don't involve the end user in your threading decisions. Okay. All right, so here I have this, and you can see that, hopefully you can see, it might be very hard to see in this small thing, that I'm flicking and it's working, and I press refresh and it's still working. Okay, I'm flicking, it's still working. It's off fetching though, okay? And you'll see it really clearly here. Watch, refresh, I'm moving, it's working fine. When it reloads, I lost my selection, of course, because it reloaded all my data, right? Refresh, okay? Working fine, see? Okay, so my UI never paused, and yet I went out to Flickr and fetched all new data. Question, Mike? Sorry?
Or what would happen if you didn't put it back in the main queue? The update, if you just
yeah, so the question is, I think you're asking, can you show us what would happen if you didn't put it back in the main queue? And the answer is, I can't really show you because it's non-deterministic. You just, if something's running in another thread and it's not thread safe, you just don't know what data structures you might be stomping on. It might work fine. Okay, but it might totally get everything messed up. Question?
What happened if you call reload data so it's going in the background, it's going to like download some stuff before it goes back to the main queue. But then you, while it's loading, you tap on one of those cells and segue to like another view controller.
Okay, that's an awesome question. So the question is, what if I hit refresh? I hit refresh, and then I click on something, and something happens that like we segue away, like this just goes away. That really, you probably want to put something here in set photos, like if self.tableview.window, then reload the data. In other words, if this table view is on screen, reload the data. Otherwise, forget it. And UI table view controller always reloads the data when it first appears. When view will appear, table view will reload the data for you, obviously. So you could make some optimizations here if you thought this was going to happen, that people clicked away. And again, if I got all the way through this demo, and I'm contemplating whether I'll just do this on Tuesday, I might. You would see that, in fact, we do have that situation, because when I click to show a photo, it's offloading in another thread, and I could click and show a different photo, and then that other photo would show, and the results of the other one is just basically lost or wasted. So we would have that situation in that case.
Did you ever have a situation though where you put something else on a separate queue that would refer back to the main queue, that if you would segue away, it would segue back or like change your UI?
Yeah, so the question is, would you ever have a situation where you put a block of code on another thread's queue, and it posts something back to the main queue that would segue it back on screen if it was off screen? And I would say that would be very disruptive to the end user. It's possible that that might be good UI, unlikely.
Well, I'm saying, like, is that something to watch out for?
Yes, that is the question. Is that something to watch out for? Yeah, I'd watch out for that. You would find that in user testing pretty quick, but yeah, you don't want to be jerking the user around with UI changes that are happening at random times based on when threads run, okay? Because threads run non-deterministic time. So I have 4 minutes left, so I'll show you something interesting here, which is we don't give any feedback to the user when this refresh is happening. So I'm refreshing my UI. Ooh, it looks great. It's worked fine. And it's off fetching, and the user doesn't even realize it's fetching until the new data comes in and they lose their selection or whatever. What would be a nice way to give some feedback? So here's one way is, you see this refresh button? If I've already pressed refresh, then pressing it again is a waste of time. I'm already in the process of getting it. So what if I replace this refresh button with a little spinning wheel? You know the little spinning wheel? It's like I'm doing something, okay? That would be a double winner. One, it would show that something's happening, and two, it would get rid of that refresh button while the refresh is in process. So how do we do such a thing? Okay, we can do this all right here in refresh. Okay, there is a class in iOS called UI Activity Indicator View. Okay, it's just a UI view, and it has the little spinning wheel. Okay, I'm going to call it spinner. I'm going to make one here. Alec init. Its designated initializer is the style. I'm going to get the default style, which is style gray, but there's a couple others, white and white large. You can actually even set the colors of these things, but it's kind of some default styles. So I got my spinner. I'm going to start my spinner animating. Okay, there's a method in UI Activity Indicator View called start animating. So that's going to start it spinning. Then I'm going to replace that bar button with a bar button that has this view as its only contents. Okay, because you can have bar buttons with strings, like refresh, and with images, some static image, but you can also have some that have their own view, and this is how you do that. UI bar button item. In fact, I don't even need to do that. Let's just go straight to self.navigation item. So this is what I was talking about the navigation item. Right bar button, that's where the refresh button is, right? It's in the right bar button. Equals UI bar button item, Alec, init with custom view. Okay, see this init with custom view? And I'm just going to give it the spinner. So that is going to replace the right bar button, if I'm inside of a navigation controller, which I am, with a bar button that has a custom view, which is that spinner that I just did. Now, of course, when the thing's done, I need to put that refresh button back, okay, because I might want to refresh again later. So when is it done, and when can I do it? Back here in the main queue. So I'll just say right here, self.navigation_item.right bar button item equals, and where is that refresh button? We have it handy. Okay, because that's the thing that sent us this message. Okay, so that's a little tricky. All right, so let's see if that works. All right, so here we go. All right, it's working fine. Refresh. Oh, we got a little spinner. It's too bad it has to be on the thing. It's hard to see it. Can you see the spinner there? But let's do it again. So there's the little spinner. All right. Okay, so that spinner, you can obviously create it in code like this. We haven't created a lot of views in code, but here's one. You can also create that spinner by just dragging it out in Xcode and putting it in your view. The key thing is the started animating. If you're keeping the spinner around, when you send it stop animating, to make it stop spinning, there's also a switch in Xcode that you can set. It says hide when stopped animating, and you're probably going to want that. So you're going to drag out the spinner, probably have an outlet to it. You'll say spinner start animating, it'll appear and start animating. Then when you say stop animating, it'll automatically disappear. It'll be hidden. Okay, it'll still be there, but it'll be hidden. And then when you start it again, it'll come back, okay, if you want to start it again. All right? So that's just a little thing for your homework that you might need. All right, so that's it. Unfortunately, we had technical problems here with the network on this thing, but here's what I'm going to put into the thing that I'll post this code as is, because it's kind of interesting just as it is. But what I'm going to post in the little extras is really three things. Okay, one, I'll make it so that when you click on a row in the table, it actually downloads the image and shows it to you. Okay, and all that's going to do is use this Flickr Fetcher API right here, URL for photo. It's going to get an NS URL. I'm going to use NS data to get the contents of that URL as bits. Then I'm going to use UI image to turn that into those bits into an image. Right? Then I'll just set an image views image to be that. The next thing I'll do is sections. So we'll have our table here divided up into sections by the owner. This little word that you can't read because it's so small is the owner of the photo. So we'll divide it up into sections, so you'll see that. I'll also throw a spinner on the photo side. When it's downloading the photo, we'll have a little spinner running there as well. Okay, so that's what I'm going to do in the extra one. Probably, now that I'm thinking about it, probably won't do it on Tuesday. I think it's pretty self-explanatory to go look through there. And I think that's pretty much it. So if you have any questions, I'll be here for a short time today. I only have a brief time.
For more, please visit us at stanford.edu.